Hello guys, we are back with our next lecture. In this lecture, let us go through the next type of ARQ request. So in the last lecture, we discussed about traditional stop and wait ARQ, right? Okay, so if you recall, what is the major disadvantage in it which made the introduction of a go back and ARQ, guys? So if you recall, in that we are forced to transfer only one frame, right? So once that frame has been received, we got acknowledgement. Then we will transfer the next frame. So it is a frame by frame process. So is it fast, guys? The answer is no, right? Yes. So that is the main reason why we will not be using a stop and wait ARQ, traditional stop and wait ARQ. So we are going to use some other thing, but let us learn about go back and ARQ, guys. Okay, so go back and ARQ. Okay, so previously the window size was, there was only two options, right? So we used to give either 0 or 1, right? Yes, but here we will give them in terms of 2 power m. Okay, so we'll be giving some size, guys. So basically this size is nothing but the number of bits which are going to represent the numbers. Okay, so if there are 2 power m cells, so I'll be calling these as a cells, guys, or frames also you can say. So there can be maximum 2 power m slots, guys. Okay, so among those 2 power m, I will give one slot for the receiver. So basically when the receiver receives our packet, it should store that packet somewhere, right? Or else it will be really tough for it, right? Yes. Okay, so once the receiver receives the packet, it will store in its buffer, right? Yes. So that, for that reason, I'm giving one as a window size for the receiver. So basically we call it as a window size, guys, in terminology. Okay, so the sender window size will be 2 power m minus 1, right? Yes. So basically if the m value is a 4, the sender can send 15 bits continuously, guys, and the receiver will receive them one after the other. Got it? Yes. You got the idea, right? Yes. Okay. So once we go through the example, you will get more idea. So don't worry. Okay. So if we recall, in stop and wait ARQ, the sender size is one frame, which is not at all a good idea. Hence, in go back NQ, we give the maximum space to the sender. So basically, I just give one slot or one window size for the receiver, because at least he should store one frame, right? Yes. Okay. And the rest all frames I gave directly for the sender, right? Yes. Okay. So if you take a small example, okay, here I took the example in this way. So if n equal to 4, 2 power n, that is nothing but 15 for sender and 1 for the receiver. So that's what I have explained, right? Yes. So let us now go through the diagram. Okay, so in the diagram I used some other different type of terminology. So here I took only from 1 to 6, guys. Sorry. Okay, so it is also from 0 to 16, sorry, 0 to 15, the total number of frames. So let us start. So how many can I send continuously, guys? Assume that I can send 15, right? Indirectly. Yes. So for us, easy understanding, let me send 4 packets or 4 frames at once. So I sent first frame, I sent second frame, I sent third frame, I sent fourth frame. Okay, so the receiver has received them successfully and it started sending the acknowledgement. Okay, so I received 0th acknowledgement. Okay, and remember one more thing, guys. I can send, so let us recall. So basically the value of m is a 4. Okay, so this many bits, this many frames I can send, guys. So I cannot send 16 out of 16 frames. I was a bit confused at that time. So basically this many packets or frames we can send at any moment of time. So as here I told, here in the example we are taking this to n equal to 4. So that is the reason why I am able to send 4 packets at a moment of time. So first I will send those 4 packets and I got the acknowledgement of 0. Instantly I sent the 4th packet. I got 1 acknowledgement. So instantly I sent the next packet. I got 2nd acknowledgement, but unluckily I did not receive it, right? Yes. Okay. So before I received it only, I sent the 6th packet also. Okay. So at this time, okay, so as a 2nd packet was not received successfully, so the only disadvantage here is so the sender can store 4 packets, right, at max. Okay, so indirectly he can store multiple packets, but when it comes to the receiver, he can store only 1 packet, right, because his window size is only 1. Okay, so that is the reason why if a 3rd packet comes, if 2nd packet comes, it is stored here. Okay, but 2nd packet was failed, right? Okay, so just to give me a second, guys. Okay, so I think my case will not be working, because if my case I want to prove it, so basically this packet shouldn't even be received, right? Yes. So basically assume that this second packet wasn't even received. Okay. So first packet, 0th packet we have received, first packet we have received. So now we are waiting for second packet, but unfortunately we got third packet. So I am waiting for second packet, but I got third packet. So what I will do, guys, I will discard this packet and I will be in search of this second packet, right? Because I am not having any storage to store this value. So I am forced to discard it. So I discarded that third packet, and after that fourth packet came, after that fifth packet came, after that sixth packet came. So continuously I discarded each one of them, right? Yes. Okay, so this second packet acknowledgement, like this time will be there, right? So the timeout time, to be clear, right? So assume that the timeout time has been completed till here. Okay, so what will we do after timeout time, guys? We will resend the particular packet, right? Means this packet should also not be start sending. Sorry for the silly mistakes, guys. Okay, yes. So basically from here to here we are going to resend it, right? So basically the second packet it did not receive. So now what I will do is I will first send the second packet. Okay, so it will be received. So second will be inserted, third, fourth, fifth. So in this way it will work, guys. Okay, so what exactly is happening here is, so whenever a packet is being lost, whatever packets are received next will compulsory be rejected or discarded, because we are not having any storage space to store them, right? Yes, so that is the major disadvantage with respect to this go back and ARQ, guys. So if you recall, what is the name, guys? Go back n. So if you observe carefully, second packet was not received, so we went back up to second and continued from there, right? So that is what the name also suggests. Got it? Yes. So now you are getting the idea, right? So everything is slowly connecting, right? Yes. So whenever a packet is missing, so whatever packets comes after them, everything will be discarded until the same packet which we are in search of comes. Okay, you got the idea, right? So that's what I think I have written here. Okay, so as here sender can send a maximum of 15 frames, but receiver can only process 1 frame. Hence, if frames are received in order, no issue. So basically if everything is coming in order like 1 2 3 4 5 6 like that, there will be no issue. But if one frame is missing, then all after frames which came after that particular frame will be discarded, right? So they should be resent, as a receiver can't store them because we are having only one slot, so only one frame can fit. So the frame which we are in search of is the second frame, but that frame is not coming, right? Yes, so that is the reason why it is called as a go back n ARQ. So we will be going back n frames. Got it? Yes. It's a quite interesting topic, guys, if you ask me, right? Yes. Okay. So now I hope everyone got a clear idea about this go back and ARQ, right? Yes. Okay. So in the next lecture, let us discuss the last, I think we should go through the formulas and problems, right? Yes. Okay. So there is a small change in the formulas, guys. So the small change is, so to calculate window size. Okay, so window size is nothing but 1 plus 2a, guys. So what is this a? If you recall, so I think it will be easy if we derive it, guys, rather than remembering the formula. So let us try to derive it. Okay, so what is the formula which we learned previously, guys? Efficiency is equals to TT by TT plus 2 into TP, right? Yes, but here how many frames we can send, guys? If you recall, we can send multiple frames at a time, right? So we are not forced to send only one frame. So that is, we are calling it as into window size of a sender, guys. Got it? Yes. So how many windows or how much frames the sender is sending will multiply with it. Got it? Yes. Okay. So here, let us assume that we want to find this window size, the best value for window size. So if we are in search of a best value for window size, always the efficiency we want a maximum, right? So let us assume efficiency as 100%. It is nothing but TT into WS by TT plus 2 into TP. Right? Yes. So let me send this whole part onto the other side. It is nothing but WS is equals to TT plus 2 into TP by TT. Right? So if I just cancel it, it will become 1 plus 2 into TP by TT. Right? So if I assume this as a, it is nothing but 1 plus 2 alpha. Let us assume it as alpha. So this is the window size, right? Yes. So this will be the best case, right? Yes. So few students will be having a doubt like, okay, so if this is the window size, then what about the sequence numbers? So the sequence numbers will be the ceil value of log base 2 of this value. Got it? Yes. So these are the formulas which you should remember, and the most important formula is this only, guys. So here we are multiplying with the window size of the sender. Got it? Yes. Okay, so now you got an idea, right? Yes. So now let us go through a gate question, that is a gate 2005, guys. Okay, so the given question is okay, so I think I can explain it in the book, or shall I solve it, guys? I'll be solving it because few students will be saying like explaining in book isn't a good thing, right? Yes. Okay, so they gave the distance as 8,000 kilometers, guys. Okay, similarly they gave the bandwidth as a 500 into 10 power 6 bits per second. So they gave the speed as 4 into 10 power 6 m meters per second. Okay, so they give the length as a 10 power 7 bits, and they clearly give that the efficiency is a 1. Okay, so now they are asking how many bits are needed and what is the total window size of the sender and window size of the receiver and the total window size. Okay, yes. So now let us start calculating. Okay, yes. And to be clear, this type of question was given in GATE CSE 2021 set 1, guys, in my set only, but I did a silly mistake in it. Okay, yes. I'll be explaining you like what is the silly mistake which I did. Okay, yes. Okay, so now let us go through the question. So basically here we need to calculate the window size, right? Yes. Okay, yes. In my question also they asked the window size only, but I did something else. Okay, yes. So first let us calculate TP, guys. So TP is nothing but a distance by speed. So they gave the distance as 8,000 kilometers. So let us convert it into meters. By speed they gave it as a 500 into 10 power 6. Sorry, it's not this. So 4 into 10 power 6 meters per second. Here also it is meters, so meters will cancel. 1 2 3 4 5 6. So this 6 will cancel. This and this 4, sir. Sorry, 2, sir. So it is nothing but 2000 milliseconds, right? So for easy understanding, let us write in milliseconds, guys. Okay, so it is 2 seconds, so that is a 2000 milliseconds. Okay, similarly the value of TT is nothing but a length by bandwidth. So what is the given length? That is a 10 power 7. They gave bits, right? Okay, so it is nothing but a B. And similarly they gave the bandwidth as a 500 into 10 power 6. So as we convert it into milliseconds, so let us convert this also into milliseconds. So B will cancel. So it is a 7 above. Oh, sorry, there is 10 above, 6, 7, 8. So here there will be 2 left out. Okay, yes. So from that I can cancel 1. So it will be 20, right? So 100 by 5 is nothing but 20. So it is a 20 milliseconds. So I got the results. So they give the efficiency as 1. So efficiency is equals to TT into window size by TT plus 2 into TP, right? So we know the efficiency value as 1. So 1 is equals to TT into window size by TT into 2 into TP. Sorry, here it should be plus. Okay, yes. So we already know that. We clearly know that window size is equals to 1 plus 2 into TP by, that is a 2000 divided by 200, right? So it is a nothing but 100, sir. That is a 200. So the window size is a 201. Okay. So this is the sender window size, right? Right? Yes. So what is the receiver window size, guys? So if you recall, the receiver window size in the normal go back and ARQ is a 1, right? Yes. So we can conclude that the total window size is a 202. So in the GATE 2021 set 1 question, so they asked this value, guys. So basically they gave a question like this and they asked this value. So I have calculated till here perfectly, but what I did is I applied a log and I found how many bits are required. So what is this log value, guys? So for easy calculation, let us use a calc. Okay, so log base 202. Okay, that is a nothing but 7 point something, right? Yes. So if you want to represent that 7 point something in terms of bits, we will always take 8 bits, right? So we'll take the seal value and it is 8 bits, right? Yes. So we need 8 bits. So I also converted this and I wrote the answer in bits. It's a fill in the blank question and I got around 5 or 6 as the answer and I wrote it as in bits, right? Yes. But the original answer they asked is this answer. So I lost marks there. Got it? Yes, it's a 2 mark question to be clear. Okay, yes. So these type of silly mistakes we'll be doing, guys, because I read the question and I understood that we need to calculate that. But in the flow, I calculated this and I kept that as the answer. Okay, yes. So we'll be doing these type of silly mistakes. So always concentrate on the question, guys, like exactly what they are asking. Okay, yes. So anyway, we'll be discussing many PYQPs this time. So these type of silly mistakes will be covered, and I think you will also not be doing any kind of mistakes like this. Okay. Yes. So the most important formula which you should remember from here is this is the important formula, and this log conversion I think everyone can remember, right? Yes. So this is the most important formula and this is a window size of sender only. Okay, yes. So now I hope everyone got a clear idea with respect to this question. So in the next lecture, we'll be discussing about the next topic, that is selective repeat ARQ, guys. So it is the advanced version. So basically in this version, what is the disadvantage, guys? Here we are just resending some frames again and again, right? Which is not at all a good thing, right? Yes. So that is the reason why we designed selective repeat ARQ. So this could be an ideal case because this is a good ARQ, guys. Okay. And remember one more thing, these ARQs, okay, are really important to understand, guys. Okay, yes. And in few books, instead of writing them as ARQ, these questions are given as the name sliding window protocol also. Okay, so please remember that also. Okay, yes. So I hope everyone got a clear idea. So in the next lecture, we'll be discussing about selective repeat ARQ. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.